Hello. Today I want to give you a brief introduction to a MATLAB library that helps you model light propagation within volumes or cuboids. In particular, I, along with my friends Ritvik and Arjun, used this very software to model skin reflectance in MATLAB, and we studied the relation of skin reflectance with blood oxygen concentration. And yeah, we thought it would be fun to share what we learned and about the software and how to go about using it. So this video will basically serve as like a very small glimpse into what this software known as MCMatlab can do for you. And yeah, this would be a good starting point for anybody who knows MATLAB and wants to get started with um, projects like skin reflectance or light propagation in general. So without further ado, let me share my screen and begin talking about this paper that came out in 2018, I believe, and it describes everything you want to know about MCMatlab by Marti et al. Um, and they go through fundamentals of how they use Monte Carlo for implementing um, uh, modeling of light propagation in different volumes. They describe the different parameters like the absorption coefficient, the scattering coefficient, the anisotropy factor, and there's also the refractive index that we will talk about for every single medium that you try and model. Um, and just to give you an idea, these are some visual outputs that this software produces. This one is basically showing you just the geometry. These ones are show you, I think, so this one is the fluence rate. So it shows you how much light flows through every single interface. And this one is, I think, showing you absorbed power. So it's showing you how much light was absorbed in what portion of the volume. And we'll be able to see all of this in the example that we run. You might want to note here that this is the GitHub repository that stores MCMatlab. It is very frequently updated. The developers are really active. Um, they're constantly fixing bugs, adding features at a rapid pace. Uh, the README will contain a good amount of documentation for you to go through all of the parameters or MATLAB variables or MATLAB functions that you want to learn about. You can find here. We will discuss a few of them today. And it starts off by describing how MCMatlab is basically a Monte Carlo simulation for modeling light propagation in 3D voxel space, as we spoke about. And MCMatlab, as you can see, can also model fluorescence. It can also model heat propagation as well. So yeah, I guess this part here, heat diffusion in the same voxel space. There are a lot of advantages to using MCMatlab. I think the closest competitor, I think, would be something called Velo MC. But the benefits of MCMatlab come from how it is open source. It supports GPUs for faster runtimes. Um, uh, it supports, again, the fluorescence and heat diffusion, which Velo MC does not support. And in general, a very active community that keeps releasing new updates to this repository every couple of months or so. Um, and this is where you can download all of the latest files and store them. Uh, what we will do today is understand how to begin programming in MCMatlab, and let's look at an example code. So this is the code that we worked on for our project, the one that dealt with measuring skin reflectance for different kinds of blood oxygen concentrations. Um, so let's go quickly through the different components of uh, an MCMatlab code, and all you have to do, okay. So let's talk about the first important thing, which will be right at the bottom. There are two functions. The first one is called media properties func, and the second one is called geometry definition. Both of these will be useful for you to define the way your geometry should look like, define the way your cuboidal volume of tissue, or yeah, in our case it's a tissue, but in general it's a volume through which you want light to propagate. The first function we talked about, called media properties func, lists down the different kinds of media that you want to include in your volume of uh in your overall cuboidal volume. So all of these are different example indexed with different serial numbers. So for example, this is the one for epidermis. There are 4 properties that we can define for every single material. This is the absorption coefficient, this is the scattering coefficient, this is the Hennier-Greenstein anisotropy coefficient, and this is the refractive index. These are in per centimeter, and the other 2 are unitless. Similarly, you define all the other kinds of media that you want to include in your model. So you can see for the skin reflectance problem, we have epidermis, 2 kinds of epidermis. In fact, we have upper dermis, we have blood, we have lower dermis, and fat, and we just included this black with a really high absorption coefficient so that all the remaining light gets absorbed inside. So that was the first major component of defining of how to define a geometry within MCMatlab, and we are done with that. The geometry definition comes in this second function that we spoke about. So this second function will actually take a matrix the size of your cuboid, and the value you set here corresponds to what each of those voxels, what layer each of those voxels belong to. So if I write 1 here, it corresponds to the medium 1 that we defined, which as we saw was air. So just like this, I have modified the values of this matrix M to basically reflect whatever geometry I wanted, which we'll see in a bit. And just in this way, using the media you defined previously, you can declare how you want to arrange your layers physically in your cuboidal volume. Great. So I think what we did here first was we made everything black first. So we are working on a background of black. We made the first layer air, the second layer epidermis, the third is upper dermis. This is the first layer of blood within the upper dermis. This is the second upper dermis. This is the lower dermis, and then there's another kind of complicated cylindrical. It kind of models a cylindrical veiny structure of blood. So that is blood 2. And when we run this program, you'll see how it exactly looks like. The next important thing to do is define a model, an MCMatlab model, and this model has several parameters. So the NX, NY, and NZ. Okay, so let's start with the LX, LY, and LZ, which basically define the dimensions in centimeter of each side of your cuboid. And NX, NY, and NZ define how many bins you want to divide each of those. You want to divide your cuboidal volume along each of those dimensions. So we did a 0.5 by 0.5 by 0.5 centimeter cuboidal volume. It has 500 bins in the Z direction and 101 in NX and in X and Y respectively. The second part of the setup is going to be properties of light. So number of photons requested in our case is 1E5. Do note that simulation times are very highly dependent on the number of photons you use. So they are linearly correlated basically. The boundary type tells you which of the surfaces of your cuboid can allow light to escape. Wavelength can be a single number in nanometer, which in this case, I think we are sweeping over different wavelengths, which is why you see this. The source type can be one of several types, as you can see here. pencil beam or point source or plane wave or so on. I think in this case, we are choosing a plane wave, and these are the focal points of the light source. In this case, they are not relevant because a plane wave does not have a focal point. These are some global variables we defined, which you need not use. So these are not specific to MCMatlab. These are very specific to the skin reflectance problem that we're working on. And finally, I would show you how to run a Monte Carlo simulation. As you can see, it has constructed the geometry for us. It is going to run Monte Carlo simulation in the background for 5 times. And here you can see the results of our simulation. So let's scroll up a little bit. It ran Monte Carlo simulation 5 times. Here you can see that the amount of light that was absorbed and the amount of light that was reflected back. So see how 2.39% of reflected light is reflected, of incident light is reflected back. And this exactly corresponds to the reflectance value that you see here. So it's roughly 0.024 is what we see. And let's start looking at these beautiful figures now. Figure 1 basically shows you the geometry that you created, right? So this will, I think, make sense once you look at the geometry definition that we explained a few minutes ago. So we have one very small layer of air, we have epidermis, we have upper dermis, blood, another layer of upper dermis, some lower dermis, and then within the lower dermis, we have some kind of cylindrical blood vessels which run along this axis. And then the rest of the volume is basically black, so that we can absorb anything that gets there. The figure 2 will show you the distribution across different media that you use for the absorption coefficient, the scattering coefficient, and the anisotropy coefficient. Figure 3 will show you exactly where your light was absorbed. So in this case, light was absorbed within the first 2 layers, so epidermis and pretty much all of blood. Figure 4 will show you fluence rate, which means what amount of light entered each of those voxels is basically what is shown here. You can also zoom in, as you can see. Hold on. You can zoom in and see better. You can always do that. So you can see that blood and epidermis are the main culprits here for absorbing most of the light, and which is why blood oxygen concentration can be measured using skin reflectance values, because blood oxygen concentration changes the way the blood layer absorbs or reflects light. And the final one here is showing how light escapes, basically. So this is the light escaping the top surface. You can see there is a good amount of light escaping the top surface. And there is zero. There is close to zero light escaping the bottom surface, which we expect because the final layer was black. So highly absorptive final layer. Great. With that, we covered a bunch of very basic concepts relating to MCMatlab. As we discussed, they have tremendous documentation. They have all of these examples that you can go through to understand how to run MCMatlab. Yeah, with that, if you want to use this software for any of your projects or any of the things you're working on, I hope you feel confident enough, a little bit more confident after this video. With that, I think I'll take your leave. Thank you so much. I hope you gained something good out of this video. Thank you so much.